Okay. Oh yeah, I'll add this later on. I just want to show you use this table here to kind of show you why joins are important. You probably know by now why they're important. So this is an example of a table of, let's just say, employees table, okay, and very typical, it's just an Excel sheet, right? You do this in Excel, and the idea of a table such as this is really to give you a really nice overview of what's in the table in terms of say, employees, right? So who they are, the IDs, the names, and the age in this example here, what department they're in, and the position, and maybe a pay, some kind of pay code. SA, let's just say we call that for salary, HR for hourly rate, and then maybe others, maybe UN for unpaid or something, right, for intern. And then the description will be like a job description, not job, but the position description, and that could also be part of it as well. That. So this is a typical table, and if you want to look, if you look at this table here, the number here, this doesn't really count. This is just to show you what line numbers, right, for the sheet. And something like this, let's say the employee ID is unique, right? If that should be unique, you cannot have duplicate IDs. But other things could be duplicated in this example here. Just a tiny example here to show you why we need join. So the idea of join is basically combining data from multiple tables to generate a list that will look something like this, right? It's easy for us to see. I want to see who is Bob Barker, for example, and what he does, and so on. So you look at this table, it tells you his ID, his name, his age, his position, and so on. So really nice, okay? But in terms of storing this data in a table is not efficient. Okay, the reason is because, let's just say that someday that maybe Peter Pan, he decides to change department. Okay, he wants to change it to a different department, and so it's no longer on the HR. No longer the IT. He wants to be changed to, I guess, the news department, right? So this Excel sheet, it's pretty easy to do. If you just 10 people, you can use this to manage your data. You don't need a database to do it. But let's just say you have 100, maybe 100,000 records here, and you want to change, Peter's department to news. So what you can do is basically you can go to find his name and then just change it to news, and you're done. Okay. And then let's just say that next week all the IT departments has been changed, or maybe the HR, right? The HR has been changed. Not changed, but you say, you know what? We don't want to be called HR anymore. We want to have the full name, human resources, in there, right? So how do you go about doing that? And with an Excel sheet, you can find it yourself manually, or you could, do a control find and replace, right? You can do find and replace all of that. I could do something like, I want to change the HR to human resources, like that. If you do that, though, it's going to change everywhere else that it has the HR, right? So if you do this, you see that HR has been changed. The HR here is also changed. That's good. But maybe other places might change too if there's an HR in there. Like if you notice here, the hourly rate has been changed to HR, right? You don't want that to be changed. Okay, so it's not really efficient in this example here. But you can say, I could just highlight this column here and do a find and replace in there, which is fine. You can do that. You can do that. That's fine. But what about over here? I want to change that too. Okay, then you repeat that. So every column you do that manually, right? So that's really laborious work. You don't want to do that, right? So what you do is basically you cut this out and move it into a separate tables. Okay. And so so that way, if they changed the department name to something else, then you just basically change in one place and you are done. Okay, so you break this down to something like this, right? This is more efficient to manage. Of course, it's hard to see. So for your result, you may not want to see this because you can't tell what's department 1, right? You don't know what that is. But in terms of retrieving data, this is the ideal way, and this is part of normalization. We'll do that next time. Okay, so you will track each ID, each department ID and the position and so on, right? So by doing that, it's much easier because ID 1, it doesn't matter what As long as you don't change this number here, then whatever this name here can be changed will always be reflected out there. Okay, so you change in one place only, this single table, and then other places can also be changed automatically. Okay, this is how you manage your databases. That's why it's all spread out into their own tables. You have lots of tables all spread across the server, and they're all linked together by some kind of special code, right? The key code, which we call the foreign key and then the primary key, right? Okay, so when we do that, then you want to put all this data back together to form something like this, and that's where the join comes in. Okay, that's what we use joins for. Okay, so joins, if you remember from last week, the most common type is the inner join, and the inner join gives you basically that, if you look at the Venn diagram. Okay, so the Venn diagram tells you what's needed. Okay, so this join here, what we don't see behind the scene though is that when you do a join, an inner join, do you remember the Cartesian product, right? If you look at the Cartesian product, let's go back here, you can kind of see what that looks like, which is a cross join. Okay, it's every row in A, you pretty much map every row in A to every row in B, okay, that many times. So when you do the join, it does this behind the scene. So you actually build a Cartesian table because you match the column A with every column in B. And so you build this entire table behind the scene, which you don't see it. And then the second condition comes in, which is the other part, right? We have match from table A's ID versus against table B's ID, and it only pulls, using that Cartesian product, it only pulls all those matching records out. So you get a collection of all the data from this product here, but only those that will match, and so that's the only pull that centerpiece where they intersect. Okay, it does that behind the scene, and so that's why you have a really large table. It's still kind of slow because it builds that Cartesian table, virtual table first, and then it just, after that, it would isolate those and then pull those matching data out of that table. Okay, so so it returns, right? It returns a table. It's a table, and that's where you can also output that, not just to the the text file or the output result there. You can actually output it to another table if you want. You can build another table and then, using the result of this join, just pull the data out and insert that into another table. I think the book may even have an example of that too. I don't remember. But you could do that, so you build a third table automatically. Okay, it's really useful for that scenario. So join is, that's what it does. And let's see, I have an example here. Maybe we could use like the AP example in the book here. So if you have already started the assignment, or if you've done it, you should have this in here, this AP example here. And it's kind of small. Let me see if I can make that a little bit bigger. Graphics here. Okay, let's see. Yeah, much better, right? Okay, so this AP here, this AP table here, that's why when you want to build or run queries, you always want to see the diagrams, okay? Unless you know what they are. If you don't know, then use this diagram to show you what they look like. And you need to know the relationship, okay? And how they are connected, and which field should you collect data from, and which one you don't. And so let me rearrange this. So the top three here, as these two have no like, they do have like related IDs or fields, right? The vendor ID here, they are related, but somehow they are not connected. The way it's designed, you could connect them together by that ID there. But if you look at this diagram here, this is part of your homework assignment, right? It's kind of small. Let me rearrange this. You can move this around over here. Let me move first, and I will zoom in. So when you join tables, okay, look for fields that are related. When I say related, means like usually when you design a table as a DBA or you design yourself, if you want to connect two tables together, this and this, right? Just like the Excel sheet I showed you, if you want to connect the employees table with the pay code or with the department table, you have to match it in some way, connect it in some way. They have to be related in some way. So this table, the vendors and the invoices table here, you see that, and when we design this later, you can decide and choose which one should I have it connected to. Do I go with the invoice ID or do I go with the vendor ID? In this example here, they are connected to the vendor ID. So this is the vendor ID, vendors table has a vendor ID. The invoices has its own invoice ID, but also has a vendor ID here. So if I look at this, you can see that, okay, so therefore these two are related through this vendor ID field because they both have the same field in both tables. So when you join them, you should join both tables based on that field. Okay, it should be common in both fields. I mean both tables. Sometimes they have a different name, maybe kind of very related but a different name. It could be something a little bit different. I'm not sure if there's another. Well, yeah, it doesn't have it, but it doesn't have to be the same name. That is not required. But in terms of designing, usually that's the case. Okay, if it's not the same name, it's really hard to match them up. It doesn't mean that you can't match it with other fields. I could check as I combine these two tables here. I'm going to compare the vendor ID against the invoice ID. I could do that, which is fine, but then you get a completely different result because maybe those numbers they don't even match, and you may not get what you want, right? So typically you match the fields that are related. So if you do this, it will. So the vendor ID here, the first record, it will look for, let's just that's ID of 1. It will go take the number of 1 and go into the invoices table and match that field, vendor ID, the same vendor ID, and every record it matches, try to match the number. If it matches, then it pulls that out. It keeps going down the whole list. Okay, so you get a whole list of data. So that's what you have in what's called like a Cartesian product, right? And then you move to the next record, which is ID 2, and you do the same thing. You match against the invoices ID, and it pulls those out. Okay, so and then you would, if you add a third table, let's say the terms table here, you add this in here, depending on how you do this. But once you add this in here, so you know that these two are already connected, right? And then this one here is related to both tables, and this one here is you have a terms ID. So this one here also should have a terms ID somewhere in here. Okay, as you can see, it has a related. The name is a little bit different. It's default terms ID, but I bet that's the name that it's used in this field, right? That's how they're connected, because this side doesn't have a vendor's ID. Okay, so it connects the terms ID with the default terms ID here. You can choose that. Or this side, I could choose the terms ID with the terms ID in here. Okay, so they are related. So since they're all three related, you can pick either one, and it should get the data out of those that table, the third table there. So it really doesn't matter which one you use in this case, because they're all related. If let's just say it does not have this line here, this one is not here, then you wouldn't be able to match that with the vendors table. It would have to be the terms and the invoices only, right? Okay. So let's just see. I have vendors and terms. Okay, so that's the diagram. And if you go in here, and if you write a statement, so the join has two types, the inner join. So inner join has the implicit type. This is not preferred. It used to be popular, but it's not anymore because I think it's just not really useful. But you see that once in a while. Some people will still use it. So let's just say if I do if I select from the vendors, if I join that with the invoices table, you'll see that in the book. I think you might have an example of that as well. Some people, you actually do this. This is actually a join. You join two tables, and this is called the implicit in a join, okay, without using the join keyword at all. If you do this, then this is the same as a Cartesian product, okay? And just to show you that it's the same, let's just do this. We'll do a select everything from vendors, right? And we'll do a cross join the invoices. Let's see if that is true. So the implicit join is actually it produces a Cartesian product, okay? And if you run this now, okay, so I have the first table here, result here is the join, implicit join. I have about 13,908 rows. The second table, if you look at this, you have the same number of rows, okay, 13,908. So it is exactly the same as that Cartesian table product. So that's why it's not really really useful in this example here. If it's a small table, you can see it, but if it's large like this, then it's not really useful. Now, let's just say if you use the regular inner join, if I go select from the vendors, right, and inner join, or just join the invoices, okay, and then if you use this syntax, then you need the word on those two records or two columns that are related. In this case, it would be the vendor's ID. So vendors, and let me use that alias, okay, the I V and then the I, just so it's short. You have to type that whole text. The vendor's vendor ID, ID, match that record or the field with the invoice table and the same name. So it will match every of those. So it will build a Cartesian table, and out of that table, out of those 13,908 records, they only pull those records that have a matching ID in those fields. Okay, because some of those will be empty, right? So just to see that, let's just say up here, right up here, I'm gonna do a select from both tables, so you can see vendors, and we'll do a select from the invoices. Okay. The vendors we know, right? Vendor, if you run this, you'll see that it has about 122 and has an ID from 1 all the way down to 123, right? And each of these IDs is unique. So that's the vendor ID. Now the invoices, it has its own invoice ID, which is going to be from 1 all the way down to 114 or 115 in this case, 114, right? But if you look at the vendor ID, it doesn't have all the vendors ID, right? So therefore, some of these results will be empty. And just to see that, we can say order by vendor ID. So we can see that. So in the invoices, you can see we missed all from the 1 to 33. We don't have those vendor ID. We missed a lot of them. Okay, there's some duplicate ID here. The same vendor, but different invoice, right? So that's also unique. The same company. bought that many products. Same thing here, a lot of repeating data. So these are the related records that will be pulled out of this table. Okay, so when we join this table here, the vendors and the invoices, depending on what you put first. Okay, so the first table is the vendor, so that's the left table. This is going to compare, this is going to use the vendors column first and use that every record in that field or that table and compare that with the invoice table, the table on the right side, and not the other way around. Even though you get the same result, you still get the same result no matter what, but that's how he does it. Okay, the display will be different because the order of the tables here, but the result will still be the same. So if you run this now, you see that that's what we get. We get 114, right? Because in the vendors table, we have 122, right? 122 vendors, but in the invoices table, we have 114. So when you join them, really you should get 114, right? 114. Only those matching IDs in that invoices table. So the vendors will lose a lot of those data. A lot of these are repeating, so this number will not amount to the total of 122 for the vendors. But so this total here actually is the total inside your second table, invoices. And you can see that the vendor 1 through 33 is omitted, and so on. So you only pull all these data based on the invoices table because they match this vendor ID, and then it pull all those records from both tables. You mix them up all here together in this fashion. So you can see that the first couple columns here are from the vendors table because we pulled that first, and then the invoices after that. If I were to put the other way around, right, I should still get the same number. Record is 114. We'll see if that is true. Okay, I just swap those two tables around, and then if I run this again, okay, I still get the same number of rows, the same data, except now the invoices columns come first, and then the vendors come after. Okay, so the order is just that, but because I put a star here, I could choose and pick and choose which column should come first in that order, so that's fine. So this is a default. Okay, and the order is, again, so you would build this table. If you were to add a third table here, then this table here produces what we just saw, right? And then we use that table and then compare that new table with the third table, right? It goes in that order. Okay, so let's just say I want to join at the third table, which is the terms table, T. And then I showed you earlier that the T has both the terms ID and the terms, and then terms ID in the invoice table, or the terms ID here and the terms ID in the vendors table, right? So if I want to combine the terms against the invoices, then you want to use that column here. If I ask you to do terms against the vendors, then you use that. But in either case, you should still have the same, I think, the same result. So let's go back here and then we'll modify our here. So let's just say v dot terms on v dot term. So the vendor return default terms ID is equal to the t dot terms ID. So I'm matching with the terms ID. So I'll compare the vendor against the term, and we'll see if that's different if you will compare that with the invoice and terms. So this one, if I run it now, so I get 114. I still get the same number for 114 because it matched all the vendors. We saw that earlier, but now it added the terms along with it. So it's at the end here because it's the third table. So all the terms are here. So term is 3, 3. This is from the terms table. This is from the vendors table. As you can see, the ID, they match all the way, right? Anything's not matched will not be here. So 114. If it were to just change this to, let's just say, the I, invoice term ID, against the terms, the table's terms ID, and if you run this, you see that I still get the same result, 114. And now compare the terms ID here in the invoices table against the terms in the terms ID. But of course, the default here is from the vendor. So I see they're all related. But the order is, of course, from top to bottom, how you say it. So these two first, you get a result, you get that result. And then from this result here, compare it with this last one. And then you can just go down the list. If you have 5 tables, then that's what it is, right? You will get that same result. So it may get shorter and shorter depending on the condition there. Notice that I always use equal, equal. You could say not equal, right? You're not limited to just equal sign. You can say get all the ID here. For example, here you can say not equal to that. If you do this, you get a different result. So let's just say if I turn not equal and I sort of compare those two tables, so it returns a very different result. Okay. So I'm just saying you're not right. So you're not limited to just equal sign, and you can also have compound condition too. With this equal this, you can say and you can go on, right? You can say the vendor ID, that vendor ID, for example, or name, how we do it, ID is greater than maybe 20, right? If you do that, then that has to be true. And let me I just want to select that one. So both have to be true, have to match, and have to be greater than 20. Otherwise, it will skip all the rest. So anything is less than 20 will not be, well, in this case, it's going to be true because I think we saw the largest one was like 33 or something. So let's just say we change that to 50. Okay. And so you can see that now result is much less. It's 108 instead of 114 because all the vendor IDs now is less than 50. And if you want to sort that, you can say order by vendor ID. Okay, so just sort that you can see the result. That is now sorted. So the smallest one is 72, which is larger than 50, and they do match. And so that's how you get all the vendors with the ID of greater than 50. From here to this, you get 108. Okay, so you can do all sorts of, and that's what we learned the sorting by, the compound conditions, and all here. So this is very similar to the where clause.